Welcome students. Now that we have understood the topic of continuity, so let us go to our next topic, which is called differentiation. It's called differentiation. So the first question that comes to your mind when you listen to this word is, what is differentiation? So differentiation is slightly tricky because this is not an intuitive word. So you would not have heard this word in your English language. So continuity is an English word. When I hear the word continuity, I get some notion of what continuous means. But when you hear the word differentiation, it's not a meaningful word right now. So the question is, what is differentiation? What is differentiability? So on. So differentiation can be understood as rate of change. Rate of change. Now what is rate of change? So now let us take an example function. So let us take the function y is equal to f of x. So what is the meaning of this y is equal to f of x? So function is some rule which connects the variable x to the variable y. A function is a rule which connects the dependent variable and the independent variable. So once you have some rule which connects x and y, you can draw the graph of this function y is equal to f of x. So let us say that the graph of y is equal to f of x looks something like this. So let us say that this is the graph of y is equal to f of x. So now what is the meaning of this graph? That means as you go from one point to other point, so each point corresponds to the x coordinate and the corresponding y coordinate. It is x value and the corresponding y value. So on this graph, as you move in this direction, so you go through different points. Point means that you have an x coordinate, you have a y coordinate, right? You have an x coordinate and you have a y coordinate. So let us say that this point corresponds to x is equal to a. So this y value will correspond to f of a, right? A, f of a. That is a point. That means the coordinates of this point are a comma f of a. So let us call this point as a. Now as you move on this curve, so as you go through different points, as you can see, the x coordinate of this point is different from the x coordinate here. The y coordinate of this point is also different. So as you move in this direction, in the right direction, x increases and y also correspondingly changes. So as x increases, so let us say that after some time you go to point B. So you go from this point to this point. So let us say that you have gone forward through a distance h. So you have moved forward through a distance h. So if this x coordinate is a, what will this x coordinate be? It's nothing but a plus h, right? So now if the x coordinate is a plus h, correspondingly what is the y coordinate? Is nothing but f of a plus h. F of a plus h. Now if you go from this point to this point, the x coordinate has changed from a to a plus h, right? So the x coordinate of this point is a plus h. So the x coordinate has changed from a to a plus h. And the y coordinate has changed from f of a to f of a plus h. So will the change in x and the change in y be always same? No, right? So the change in x can be different from the change in y depending on where you are moving. For example, if you move from here to here, the change in x is this much, but the change in y is this much. So you can very clearly see that x has changed a lot, y has not changed a lot. So here the change in x and change in y looks very similar, but if you go here, if you go from here to here, the change in x is small, the change in y is large. So depending on the function and depending on where you measure on this function, the change in x and change in y might be different. Now rate of change means what? So what is rate of change? Rate of change of y, rate of change of the y coordinate with respect to x coordinate. The rate of change of y with respect to x is nothing but change in the value of y by change in the value of x. So that is called rate of change. So from A to B, if you go from A to B, what is the change in the value of x? Change in the value of x is h, right? So delta x is h. And what is the change in the value of y? F of a plus h minus f of a. So what is this value? This is the rate of change of y with respect to x between the points A and B. Between the points A and B. So I call this the average rate. Average rate of change of y with respect to x. So this rate of change is not the rate of change at any particular point. So it is the average rate of change between A and B. Now instead of going to B, if I stop here, B dash. So what is the rate of change between A and B dash? So you have to calculate the corresponding change in y and the corresponding change in x. So as you can see, this rate will be different from this rate. So if you go still closer, B double dash. So the rate of change between A and B double dash might be different from the rate of change between A and B. So the average rate of change of y with respect to x between any 2 points is nothing but change in y by change in x. So I hope you understand this. So if someone asks you to find the rate of change of y with respect to x for some function y is equal to f of x. So you need to ask 2 questions. The first question is, where should I measure? That is, if you measure at different points, the rate of change of y with respect to x will be different. The first question is, where to measure? And the second question is, between which 2 points should I measure the rate of change of y with respect to x? Because if you want delta y by delta x, we need 2 points. The first point has coordinates a, f of a. The second point has coordinates a plus h and f of a plus h. Then you can find the change in y by change in x. That is, between which points? So where should you measure, and from where to where should you measure? These are the 2 questions which you need to ask if you want the average rate of change of y with respect to x between any 2 given points. Now, if I ask you a slightly different question. Now the question is, what is the instantaneous rate of change of y with respect to x at x is equal to a? It is corresponding to the point where x is equal to a. What is the instantaneous rate of change? That is exactly at this point, what is the rate of change? Now if I ask you exactly at this point what is the rate of change, that means I am not giving you 2 different points. If I give you 2 different points, you get the average rate of change between these 2 points. Now if I want the instantaneous rate at this point, so what should we do? So one of the intuitive methods is that you bring b closer and closer to a. You bring the second point very close to A, so that A and B are nearly same but slightly different. The difference between A and B is infinitesimal. So if you bring B infinitesimally close to A. So if you bring this B very close to A and take A and B as points, the average velocity, the average rate of change which you get will be very much close to the instantaneous rate of change at A, because the interval is very small. So this is what we do when we want the instantaneous rate of change of y with respect to x at x is equal to A. So what we do to calculate this is, so we calculate delta y by delta x in the limit delta x tending to 0. It is the difference between the x coordinates of A and B is made to be very small. The delta x is made to be very small. Automatically delta y also, if the function is good, the value of delta y also becomes very small. Now the ratio of those two will give you the instantaneous rate of change of y with respect to x at x is equal to A. Because we don't have 2 points. Both the points are very close, infinitesimally close. So limit. So in this formula, delta x, the change in x is taken as h. So limit h tends to 0. F of a plus h minus f of a by h is the instantaneous rate of change of y with respect to x at x is equal to A. So this is called the differentiation of y with respect to x. This is called dy by dx. The differentiation of y with respect to x. So what is the effective meaning of differentiation? Differentiation is rate of change, but slightly more qualified rate of change. Have an adjective before this rate of change. So differentiation is the instantaneous rate of change. Instantaneous rate of change. So instantaneous rate of change of y with respect to x. So this whole phrase can be removed or replaced by differentiation. So differentiation of y with respect to x at x is equal to A is nothing but the instantaneous rate of change of y with respect to x at x is equal to A, that is equal to, usually denoted as dy by dx. Dy means the infinitesimally small change in y by infinitesimally small change in x. Delta is finite change, delta y is finite change in y by finite change in x. Dy by dx is infinitesimal change in y by infinitesimal change in x. So dy by dx is limit h tends to 0 f of a plus h minus f of a by h. F of a plus h minus f of a by h. So this is the differentiation of y with respect to x at x is equal to A. So we write it as dy by dx at x is equal to A. Or we can also denote it as f dash of x at x is equal to A. Or we can simply denote it by f dash of A. So these are different notations that we use when we talk about differentiations. The dash, the suffix, the prefix, the superscript dash denotes differentiation. Superscript dash denotes differentiation. So what we are discussing now is the differentiation of f of x at a particular value A. So what we have understood till now is that differentiation means instantaneous rate of change. Dy by dx is differential of y with respect to x at x is equal to A, can be written as f dash of x at x is equal to A, or simply f dash of A. And the definition of f dash of A is limit h tends to 0 f of a plus h minus f of a by h. So this is called the value of differentiation of f of x at x is equal to A. So if this limit exists, then we say that the function is differentiable at x is equal to a. So f of x is differentiable at x is equal to a. F of x is differentiable at x is equal to a if this limit exists. So if you want to check whether a function is differentiable or not at a particular point a, you need to try to find this limit. If this limit exists, then the function is differentiable at that point. Next, when you talk about limit, you can think about the right limit and the left limit, right? So this consists of actually two separate limits. So limit h tends to 0 plus f of a plus h minus f of a by h, and limit h tends to 0 minus f of a plus h minus f of a by h. So this is called the right derivative or the right differentiation. So this limit is called the right derivative. This limit is called the left derivative. So only if the right derivative as well as the left derivative are equal and equal to a finite value L, then only we say that the function is differentiable at the point A. So if you are asked to find the right differentiation, you just need to find the right hand limit of this limit. If you want the left derivative, you need to find the left limit. So right limit and left limit. So right derivative and left derivative. So till now we have discussed the meaning of differentiation of a function at a particular point A. Now let us try to discuss the meaning of the general differentiation function.